Hello everyone, welcome back. In this lecture we will see step down chopper with RL load. So if we connect any inductive load with the load, then what will happen? What will be the change in the output? That we will see from this lecture. So this is the circuit diagram. So this is the circuit diagram for step down chopper. So this is figure of step down chopper with RL load. So this is the load. So this is the chopper, and there is a one diode, another diode is connected. So this is called freewheeling diode. So whenever this switch is on, this chopper is on, or this switch is on, so at that time this inductor will charge. So when it will be on, then current will flow through the inductor and inductor will charge. Waveform for the output voltage. So when that switch is on, this is T on and this is T off. So when switch is on, this voltage will get this voltage across the load. Now what will happen? When that current will flow through this inductor, that inductor will charge. Now that when switch will be off, at that time inductor will be discharged through this freewheeling diode. Now in case of a voltage, it will be moreover similar as resistive load. Only there is a difference in the current, as we know that property of the inductor, that it opposes the sudden change in current. So that's why what will happen, if we see the current waveform, it will increase slowly again when switch will be off. So then also it will decrease slowly. So it will oppose the sudden change, means suddenly it will not be zero or it will not be high. So like as voltage. So this is the difference between that RL load and R load in case of a step down chopper.
The average output voltage V0 is equal to 1 by T integration 0 to T on, as the switch is, when we are getting that output voltage for the on time only, so that's why this 0 to T on Vs into dt. So that from this what we can write as Vs is constant, so Vs by T is equal to T on 0. So it is Vs into T on by T, so that Vs into alpha. Okay, now we'll find out the RMS value. RMS value of output voltage. RMS value of output voltage. So that is V0 RMS is equal to root over 1 by T integration 0 to T on Vs square dt. So this is Vs square by T into T on 0. So that we can write T on by T into Vs square. So that is root over alpha into Vs square. So that is root alpha into Vs. So that V0 RMS is equal to root alpha into Vs. So this is the equation for RMS voltage. After that we will find out that ripple factor. So ripple factor, that is RF, is equal to VAC by VDC. We know that V0 RMS is equal to root over VAC square plus VDC square. So from this what we can write, VAC is equal to root over V0 RMS square minus V0 square. So in that ripple factor, what we can write, VAC, that VAC is equal to root over V0 RMS square minus V0 square by VDC. So we know that 0 RMS square is equal to, so this we, from this what we can write, root over alpha Vs square minus alpha square Vs square by alpha into Vs. So from this we can write root over alpha minus alpha square by alpha square. So RF ripple factor, so ripple factor is equal to root over 1 by alpha minus 1 by alpha minus 1. So this is the ripple factor. Now we'll see how to find out the form factor. Form factor, we know that form factor is equal to that RMS value by average value. That form factor is equal to VRMS by V average. So that is VRMS is root alpha into Vs and V average is alpha into Vs. So that is 1 by alpha. That form factor is, so form factor is equal to 1 by alpha.